In this video, I'd like to discuss line equations. Line equations are used to denote various different lines. Okay, this is another application of coordinate geometry. You may have seen coordinate geometry be used to denote the positions of various points. You may also have seen it used to denote different triangles. You can do that by giving the coordinates of the positions of the vertices of the triangle. Okay, you can also denote lines by giving the coordinates of any 2 points along a line. So what I'm doing here is giving a second way to denote a line. Okay, and so what I'm going to do is I'm going to draw an example of a line on my coordinate axes, and I'm going to tell you what line equation corresponds to that line. In this case, it's x minus y equals 1. And now I'm going to tell you why that is indeed the correct line equation. So first, put the picture aside for a moment. Think about what solutions there are to this line equation, this two variable equation. How about 1 minus 0? Does that equal 1? What about 2 minus 1? 3 minus 2. 4 minus 3. Okay? Now what I'd like you to do is I'd like you to take the two numbers that formed all of those differences and make coordinate pairs out of them. So the 1 and the 0, the 2 and the 1, the 3 and the 2, the 4 and the 3. Next, I'd like you to see that those points are exactly the points that lie along the line that I just drew. Okay, so 1 comma 0 is right there, 2 comma 1 is right there, 3 comma 2, and if I extended the line in both directions, you would be able to see that any solution that you can come up with for that line equation will indeed fall on that line that I drew. Okay? Now, you can find line equations by trial and error for different lines. Let me show you a recipe that will probably be a little bit more doable than trial and error. But in order for you to use that, I first need to define what intercepts are and what a slope is for a line. Okay? Let me do that here at the bottom. So intercepts, let's see, intercepts, these are points where lines cross the x and y axes. Okay? And then a slope is the ratio of the differences, the ratio of the, and I'll show you what this means. These are ratios of the y and x coordinate differences. Okay, so let's do intercepts first. So where did that line cross the x-axis? Can you see? I'll circle it. Can you see that it crossed right there? And that is the point 1 comma 0. So we say that the x-intercept of this line is 1 comma 0, or simply x equal to 1. Where did it cross the y-axis? Okay, I'll circle that in purple. Okay, you can see that the coordinates of that point are 0 comma minus 1. So we say that that pair of coordinates is the y-intercept, or we simply say y equal to minus 1. All right, so to repeat, for the intercepts, you see where it crosses the axes. Okay, now for the slopes, to calculate the slope of this line, pick any 2 points along the line. So I will circle 2 points whose coordinates I have already written down. Okay? Now, what are the y values or the y coordinates of these 2 points? I hope you can see it's 0 and 1. And then the x coordinates are 1 and 2. All right? So calculate first the difference in the y coordinates. That would be 1 and 0. So the difference of 1 and 0 is the difference in the y coordinates. Now the difference in the x coordinates will form the denominator of this fraction I'm working on, and that'll be 2 minus 1. Okay, so simplify that. That gives 1 over 1, or simply 1. So we say that the slope of this line is 1. Now, what if I had calculated the differences in a different order? What if instead of 1 minus 0, I started with the top point? Well, then I'd have 0 minus 1, but as long as I do the bottom one in the corresponding order, it won't matter. So then I would do 1 minus 2, and that would give minus 1 over minus 1, which is also 1. So you see I get the same slope either way. Okay? Now I'm going to circle another pair of points, and I'd like you to find the slope with regards to those 2 points. All right, pause the video and do that now. Okay, if you did that, I hope that you saw that the slope you got was 1. Okay, in fact, if you take any 2 points along the same line, you will always get the same value calculated for the slope. Okay, so the definition of a slope is very reliable, very stable. It doesn't depend on the specific 2 points that you use. All right. Now, as another example, you may want to find the slope of this line, this green line that I've drawn. Okay, and you can pause the video and calculate that now. So I'll go ahead and tell you the answer. And by the way, the slope is traditionally denoted by the letter m. Don't ask me why. So the black line has a slope we calculated of 1, and the green, I hope you calculated a slope of minus 1. Okay? So 2 points you could have used to calculate that are 0, 1 and 1, 0. So the difference ratio would be 1 minus 0 and 0 minus 1, which gives minus 1. So that's how that works. Let me give you one more example to do. What about this horizontal line, the one that I just drew in red? Can you find the slope of that line? All right, if you did it, I hope you got a slope of 0. All right, 2 points you could have used are the 3, 2 from the black line and the y-intercept, which is 0, 2. And that would give 2 minus 2 over 3 minus 0 for the ratio of differences, which simplifies to 0. Now, I hope that clears up what intercepts are and what slopes are. Let me bring something else to your attention. Notice, or you will notice, you can do several more examples, but let me just tell you the pattern that you'll notice. If a line is going, as you move to the right, as the x, in the positive x direction, let's say, if the line is moving up and to the right, or if it's moving up as you move to the right, you'll notice that the slope will always be positive. And indeed, the black line had a positive slope. Let me circle what that slope was that I wrote down. If the line, as you move to the right, if the line is going down, you'll notice that it'll always have a negative slope. And indeed, the green line, we calculated a negative slope. Okay? If a line is horizontal, you'll notice that no matter what horizontal line you are focusing on, you'll always get a zero slope, like we calculated for the red line. Okay? Now, all of that is to help us understand this recipe that you can use to find line equations that correspond to specific lines. Okay? You will notice, and let me do this in the upper right, you will notice that a line equation for a line with a slope of m and a y-intercept, let me denote the y-intercept by b. Let's say it crosses the y-axis at the point denoted by the number b. Okay, so, and again, this is just tradition. Don't ask me why people have traditionally used these variables. So m is the slope of the line, and b is the value, the number of the y-intercept, y-coordinate. Okay, if you know those two, then you can sleep tight knowing that the equation of the line is going to be m times x plus b. Isn't that cool? All right. Now, to make this work, you need to know what the slope and the y-intercept are. Okay? Let's see if this works for the black line. So the black line had a y-intercept of 0, minus 1, so that means b is equal to minus 1. And we calculated the slope as being 1, so m is equal to 1. So the line equation apparently from this formula is y equals 1 times x plus minus 1. All right? And you can rearrange that. You could move the y to the right side by subtracting y. You could move the minus 1 to the other side by adding 1 to both sides. And by doing that, you will get the equation x minus y equals 1, which was what I told you the equation was before. Right? Now, I prefer the equation in this form where I have y on one side. Because the reason that this is a nice way to write the line equation is because you can read off what the slope and what the y-intercept is. The slope will always be the coefficient in front of the x, the number multiplying the x, and the y-intercept will always be the number added to that term. Okay, the mx term. All right. Now, sometimes you have a point, but you don't know what the y-intercept is. Now, you could draw a line through a point with a specific slope and see what the y-intercept is. But if you don't want to draw, let me show you how you can still get the y-intercept to use this formula. All right, so let me go to a new board. Or actually, before I do that, as an exercise, can you pause the video and find the line equation using this recipe for the green and red lines? Do that now, and I'll write the answer in a second. Okay, so the green line has a slope of minus 1 and a y-intercept of 1, so that gives y equals minus x plus 1. All right, for that equation, y equals minus x plus 1. The red line has a slope of 0 and a y-intercept of 2, so that gives y equal to 2. Notice that there's no x term, it's just y equal to a constant for that one. Okay, so there you have it. I'm circling in purple the 3 line equations of the 3 lines that I've drawn. Okay, now let me go to that other type of problem that I wanted to discuss. So what about this problem? What is the line equation of the line with a slope of 2 that goes through the point 1, 3? All right, so let's try to figure out what that is. So we know that the equation is going to be y equals mx plus b, we know the slope is 2, so it'll be y equals 2x plus b for some value of b. We also know that every point, the numbers that comprise every point are solutions to the equation. That's going to be the key to finding b. All right. So if I was to substitute 1 and 3 for the variables x and y, then I have to get an equation that's true for the right value of b. So in other words, I can replace the y with 3 and the x with 1. Okay, and now I have an equation that I can solve for b. So b is 3 minus 2 or 1. So the answer to this question is y equals 2x plus 1. Okay, so let that be an instructive example to show you how to do problems like this where you don't want to draw something, but you know a slope and a point. Okay, here's another example that you might see. What is the line equation of the line through the points 1, 2 and minus 2, 3? Okay, try to solve that one or think about if you can figure out on your own how to solve it. Okay, so I'll do that now. So again, we know that every line has the equation of the form mx plus b, y equals mx plus b. When we have 2 points, we know that we can find the slope. 2 minus 3, 1 minus negative 2 gives, in this case, minus 1, 3, so minus 1/3. And so right away, we've just converted this type of problem to the previous example that I did. So y equals minus 1/3 x plus b. And now you can plug in either of the points, x and y values, to solve for b. So I'll use the first one. Y equals 2 and x equals 1. So apparently b is 2 plus 1/3 or 4/3. Excuse me, 7/3. And so there you go. That's how it's done. So the line equation is y equals minus 1/3 x plus 7/3. Now you can check to make sure that's the correct answer by plugging in the points. Replace x with 1 and y with 2 and see if that gives a valid answer. So if I plugged in 1 on the right side, I get 7/3 minus 1/3, which gives 6/3. That's equal to 2. If I plugged in the minus 2, 3, I would get minus 2/3 minus 2/3. So 7/3 minus 2/3. 7/3 plus 2/3, that gives 9/3. That's 3. So indeed, the 2 points the 2 points correspond to that line equation. Okay, that's a good way to check. All right, let me close this video by mentioning a few other comments that will be good to know. Okay. So vertical lines are the only lines that don't follow the pattern that I've shown. The reason is if you tried to calculate the slope of a vertical line, you'd run into problems. All right? A vertical line is denoted by the x values of any and all of the points along the line. So for example, x equal to 1 would denote the vertical line that goes through that crosses the point with an x, the line, excuse me, a vertical line that corresponds to x equal to 1, of course, is the line that I'm about to draw. Okay, that red line. Okay? Can you tell me what is the line equation that corresponds to this blue vertical line? Try that now. Okay, the answer is that blue line corresponds to the equation x equal to minus 2. Okay, Notice that parallel lines, or think about it for a moment, you'll notice that parallel lines have to have the same slope. Okay? And the final comment I want to make, and let me go ahead and type it down, type it out so that it's clear. Perpendicular lines. Oh, first of all, let me write the observation for parallel lines. Parallel lines have the same slope. All have the same slope. And then let me close with this thought. Perpendicular lines have slopes whose product is -1. All right? So, for example, if you can look at, watch this. So, if I had a line that had a slope of 1, this red one, and I had another line that was perpendicular to that, okay, you would know the slope of the perpendicular one would be -1. If the slope of this one is 1, the slope of the other one has to be -1 because the product is -1. Okay? Let's do another example. So, suppose I had this purple line and it had a slope of, let's say, 3. Okay, if that purple line has a slope of 3, what is the slope of the second purple line if it's perpendicular? All right? So the purple line, the slope of 3. Think about what number can I multiply by 3 to get -1. All right, I hope you can see that it has to be -1/3. All right, another way of saying the same thing, instead of saying that the product is -1, you can say that each slope is the negative reciprocal of the other one.